Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Syatira binti Muhammad Saifuddin. Matrix number is 211292561. Today I would like to present about the assignment 3. So the introduction of the first question is the pressure is a measure of a force distribution over any surface associated with the force. Pressure may be defined as the force acting along the normal direction on the unit area of the surface. For example, the normal pressure on the feet of chubby person is much greater than on the feet of a slim person. However, a more precise definition of pressure P is as a below. The unit pressure in the SI unit is 2 nm square, also called Pascal. PA, absolute pressure is the actual pressure at a certain position. It is measured relative to an absolute vacuum, for example, absolute zero pressure. The device to measure the pressure are barometer, strain gauge, Bourdon tube, pressure transducer, and manometer. The commonly used to measure the pressure is the manometer. The manometer is a device to measure pressure or mostly differences in pressure using a liquid column to balance the pressure. It is a basic instrument that is used extensively in a flow measurement. It contains one or more fluids such as mercury, water, alcohol, or oil, and it doesn't need a calibration. The basic principle of operation of manometer is that the same level in contiguous fluid at rest, the pressure is the same. So these are the types of manometer that measure the pressure. First is the differential manometer, open end manometer, and lastly the seal end manometer. So next is an introduction for the second question. The fluid static, which is a deal with the problem associated with the fluids at rest. The fluid static are hydrostatic when the fluid is a liquid and aerostatic when the liquid is a gas. It is necessary to determine the total of force on them. To check the structural stability, it is also necessary to determine the point of action of the force. The point of action of the resultant total force, known as the center of pressure or pressure center. From the basic hydrodynamic equation, the force depends on the pressure at the depth considered. So the formula is a P equal to rho GH. G is known as a gravity, H is the height. So the center of pressure for immersed vertical plane. Some simplified expression are given in this section, which will reduce the calculation time. So there's three cases. The first case is a rectangle with B and depth. Second is a circle of diameter, and third a triangle of height H with the base B. So from the question 7 I choose from the tutorial, it is a case 1, so I use the formula in case 1. So next is the question and the solution. Okay, first the question is a manometer used to measure a pressure in a tank. The fluid used has a specific gravity of 0.85 and the manometer column height is 55 centimeter. If the local atmospheric pressure is 96 kilopascal, determine the absolute pressure within the tank. So the information that I got from the question is the CSG, which is a specific gravity with 0.85, height is 55 centimeter, atmospheric pressure is 96 kilopascal. So I use first I find the density of the water, which is uh, I multiply the specific gravity with the density of water, which is I get 850 kilogram over the m cubic. So when I got the answer, I can plus with the atmospheric pressure, which is 96 kilopascal. The answer for this question is 106 kilopascal. So the second question is a rectangular gate with the 3 meter high and 6 meter wide is hinged at the top edge at A and is restrained by a fixed ridge at B, as shown in figure 2. Determine the hydrostatic force exerted by the water on the gate AB. So from this figure, I got the information, which is the height of the gate AB, and I can find the hydrostatic force by using a formula PAV multiplied with the area. So PAV is equal to rho gravity plus with the S plus B over 2. This is a equation for the area. So I multiply the rho of the which is a density of the water, 1000 kilogram over m cubic, times with the gravity, which is at 9.81. Then I multiply with the S plus B over 2, which is I substitute uh, the value of S, which is a 2 meter, and B is a 3 meter. So I got the 34.335 kN over m squared. For the so next I find the total force for hydrostatic, which is I got the PAV. Then I multiply with the area. Area is the 1 times 3 meter square. So the answer is 103.005 kilonewton. The location of next is the location of the pressure center. P naught is 0 because there is no degree. So the YP is the 2 plus 3 over 2 plus 3 square over 12 times with the 2 plus 3 over 2 plus with 0 because there is no sign, there is no a degree. So the last answer is the 3.7143 meter. So the discussion is the first question needed to calculate the pressure in the tank using a manometer. The pressure in the tank is 100.6 kilopascal when the specific gravity is 0.85 and the density of water is 1000 kilogram over meter cubic. Then at the atmospheric pressure, which is given 96 kilopascal, and density, gravity, and height to get the final pressure answer. Next, the second question is to find the hydrostatic force exerted by the water on the gate AB and the location of the pressure of center. The hydrostatic force is calculated by using the formula of vertical rectangular plate because the hydrostatic force acts on the top surface of a submerged vertical rectangular plate. Then calculate the location of the pressure center using YP equal to S plus B over 2 plus with the B square over 12 times with the S plus B over 2 plus P naught. Hydrostatic force on a submerged plant surface such as a gate in the dam, the wall of the liquid storage tank, or the ship is subjected to fluid pressure distributed over its surface when exposed to liquid. So lastly is the conclusion. Based on this assignment, I can conclude that the manometer is the main device to measure the pressure in a tank because it can calculate without a calibration. The measurement is accurate if the reading is correct. Meanwhile, the hydrostatic fluid is deal with the problem associated with the fluid at rest. The fluid static is known as a hydrostatic when the fluid is liquid and aerostatic when the fluid is a gas. It is necessary to determine the total force on them to check the structural stability. It's also necessary to determine the point of action of this force. That's all from me. Thank you.